time to start the material, and let's get going in Chapter 2. And with Chapter 2, it's really about graphical displays and how it looks. And how do we organize data in things such as histograms or just cross tabulations. So what we're going to look at again is that idea of categorical data and quantitative data, and then being able to know what we do with that. When we're summarizing categorical data, what can we do? Well, we've got bar charts, we've got pie charts, we've got different things we can do graphically for them. We can also put them into just frequency tables to see what we have. Same thing with quantitative data. We're not going to do mean, median, and mode at this point. We're just going to look at summarizing data using histograms and also some other different types of charts. Then we'll look at summarizing two variables and how that looks graphically. And then I'll even give you a little bit of a teaser in what you'll do in BIA2620 and 3621, which is really the data analytics and dashboard type of stuff. So when we look at categorizing categorical data or summarizing it, we can look at putting it into some type of frequency distribution. Now, again, I want to preface this by saying we're taking a look at the Chapter 2 material, and this is more exposure than how-to. To understand the how-to part, you need to delve into the homework manager, and also any other videos that we have corresponding to this. Also, I've put these in different colors here, kind of a graphical display of the different types of graphical things we can do. And if you see, the ones in green are ones I'm really interested in you being able to do. And the one in yellow, pie charts, not a big fan of, but I'm going to show it to you anyways. Dot plots and stem and leaf we're not going to cover. So that just gives you a little bit of an idea of what we will cover and what we will not for this chapter. Last two, just side-by-side bar charts and stacked bar charts. Take a look at those as well. They do help you when looking at two different variables. Also, lastly, to look at relationships, definitely want to look at scatter diagrams and trend lines, which may not make a lot of sense now, but at the end of this class, when you get into regression, you will understand why scatter diagrams and trend lines are so important. All right, so here we go. We've got our different data, and we've taken a look at categorical versus quantitative, and now we want to understand, well, what can we do with it? So remember we talked in Chapter 1 about the type of data that we have determines what we can do with it. And this is another great example of that. So if we have interval or ratio data or quantitative data, there's one thing we can do. If we have categorical data, such as nominal or interval, then we can do certain things with that. So we're not going to do a scatter diagram with categorical data. And obviously we can't do certain things like a pie chart with quantitative data. So taking a look, just here's some data that you have. So you can tell what kind of data is this? Is this nominal? Well, it is different categories. But does one category look like it goes above the other? So you got excellent, above average, average, below average, or poor. So it's ordinal data, and it's not interval data because you can't really tell the difference between excellent and above average. You just know one is more than the other. So in this case, we have ordinal data. What can we do with it? Well, the first thing we can do is just put it into a frequency distribution and just say, well, how many said poor, how many said below average, how many said average, above average, and then excellent. And when you take a look at that in terms of a bar chart, you can see how data quickly jumps out at you and gives you an indication of people's perceptions. And in this case, you can see above average is by far the highest, and you can see it kind of looks like it's almost skewed one way, which is definitely something we're going to take a look at in this class. So with this type of data, you can see what it kind of looks like. Another thing we can do is take a look at real data. And you remember the Hudson Auto Repair example from Chapter 1. And in this case, we don't have ordinal data. We don't have interval data. We have ratio data. And with ratio data, again, we can come in and find out that the average is 79. That helps us out. But we also may want to look at this in terms of grouping data together and seeing where most of it falls. Is most of the parts cost in the 50s, in the 60s, 70s? And these are things we can do determining different types of categories. In this case, I want to go by, how about the 10s, and look at 50, 60, 70. And let's see if that's what we have here. And we do, and we go all the way up to 109, and we see, on average, you can see where the most frequencies are, and I say on average, but the most frequent costs are between 60 and 79, and then other ones are not as likely to happen. We should not expect the cost to be under $60. It only happened 2 times out of 50, and obviously $100 or more only happens 10% of the time. So in this case, you can see how this kind of works. Now what you have to do now is go and figure out how to create a histogram or frequency distribution using this type of quantitative data. So the histogram chart would look like this, and again, it gives you a clear indication. So sometimes all we care about is just getting an idea of what our data looks like, and this does that for us. Other ways we can look at our data, cross tabulations, where we're looking at columns and rows. We should like columns and rows, especially if we like Excel, and putting it into different columns and rows. The columns in this case would be our colonial, log, split, and A-frame, where our rows would then be less than 250 and greater than or equal to 250. And we can see there are a total of 55. See that value over here. Let's get a pen. You can see there's your 55 there, and that's less than 250 and any style. But if I want to know just the split frames and less than 250, that would be that value there. And so you can see how we can kind of look at things in terms of little sections of everything that we have here. And as a great example of a pivot table, which is very powerful stuff that you will definitely be learning in these 2 courses in our statistical methods class here, but definitely in BIA 3620 and 3621. So just some last little things. Again, this is nothing but exposure. I'm not trying to teach you this information at this point, just get you to understand what you need to know. The last little bit here is, what do you do with data when you're looking for relationships? And you can put it on an XY axis and look at data, whether X being, how about your education? So let's say that this part here is your education, and up here is then your income. And when I put these on the same one, so in other words, you have 5 years of college, you make a certain amount right at this point here, and that's where that went. And that could be $30,000. If you had this much college up here, and looks like, maybe if I go to this point here, right there, that looks like that one right there. And that could be that you make $50,000 after the master's degree. And so you could see how going out. Now, does this look like a relationship? Well, yeah, it does. It looks like a positive relationship. The more education that I have, the higher the salary would be if this was the case. Lucky for you, education does have a positive relationship to the amount of salary that you will make in the future. Also, by the way, GPA has a significant relationship to your entry-level salary that you will make in the future. Just a little tidbit for you there. So with that, obviously the opposite would be the negative relationship, and that means when X goes up, then Y goes down. And if you had no relationship whatsoever, that's what that would look like. So putting dots on a diagram, pretty easy to do. The idea at this point is not really to understand how or what the slope of a line is really at this point. We'll get to that in future chapters. The idea is to understand what a relationship is, and that this would represent no relationship. So what if we had this being height, I'll just put I for inches, and this being IQ. Now, do you think that your height has something to do with your IQ? Now, sitting here as a 5'7" individual, I'm hoping it doesn't. And so if we were to plot people's height on the x-axis and then their IQ on the y, if this is what it looked like, you can see that there does not appear to be a relationship between IQ and inches. And so that becomes some type of data that we could use. Now, if it was like this, now this is what I think it would be. The taller you are, the lower your IQ. And of course, I'm kidding. Being a short person, that's why I'm saying that. But, or it could be the higher the height, the higher the IQ in this case, and that would be the relationship that it shows. So with that, those are different things you can do with a scatter diagram. And obviously looking at different things. For example, here we have Panthers football, number of interceptions, number of points scored. And if you take a look at that, does it look like the number of interceptions has a relationship to points scored? So the more interceptions we get, the more points our team should score, because we have the ability and opportunities to score more points based on the fact that we get the ball at a better place on the field. So an example of looks like a little bit of a positive relationship in this case. Lastly, let's take a look at what you will learn in the future. Not for this class, so I won't spend a lot of time on it, but a data dashboard has become the new thing. And what we can do is take a look at data in a lot of different ways, slice and dice it up to give us something that looks like that. And this then is something that we can look at and get a better idea of what our data really tells us. So it's an easy way to find different trends maybe, look at anomalies in our data, a lot of different things. This is what we use in today's world to obviously understand what our large sets of data are telling us. And so with that, that's chapter 2. So what do you need to know? Definitely frequency distribution. Also learn relative frequency as you get going through the chapter. Understand how to put it into a table, and also using it in terms of categorical data, which is pretty easy. You just put it into different categories and how many frequencies do you have. And then also doing it with quantitative data and creating that histogram with it. Also understand the differences in how to use bar charts, a little bit with pie charts, and that's about all we'll really expect for graphical in this case. And then looking at scatter diagrams and trend lines as a final component to just understand how to look at a relationship, whether it be a positive relationship, a negative relationship, or no relationship whatsoever. So with that, let's get into what we need to for chapter 3 here, looking at summarizing data with mean, median, and mode, and some other different characteristics. And then we'll also tackle probability in chapter 4 as we get going. So what you'll see as we continue to go through this is now it's our opportunity to build on the next chapter. We learn this so that we can go on to the next chapter, and then chapter 2 and 3 really helps us for chapter 4. Chapter 4 really helps us for chapters 5 and 6. Chapters 5 and 6 really help us for 7, 8, and 9, and you'll see that hopefully as we get going through this.